Hello everybody, welcome back to Embetronics. If you like our content, please subscribe to our YouTube channel and press the bell icon so you will get notified when we post a new video. In the last two videos, we have seen the introduction of the Linux device driver and we set up our environment. As I said you in the previous video, let's get into the action from now. Let's get started without wasting the time. Whenever we start writing the device driver, we have to provide the device driver informations like license, module author name, module description, module version, etc. We will be providing this module information using the macros that are available in the module.h file. First, we will see the license. Whenever you create a source code or software, we have to provide the license. If you are creating a repository in a GitHub, it will ask you to provide the license. Do you remember? Like that, we have to give our modules license. These are some licenses that people commonly use. GPL is one type of open source license. Then GPL v2, GPL with additional rights, dual BST, dual MIT, dual MPL, etc. I am not going to dive deeply into the licenses. You can check on your own. The source code that we are writing for the Linux device driver is GPL. So that code is free to use and you can modify that also. If you don't want to provide your code to the public, then you can use the proprietary license. As I said, you can use this macro called module license to define your driver's license type like GPL, GPL v2, dual BST, and this is not necessary but it is advisable. Author. Using this module author macro, you can give the name that who is writing the code. For example, if you are writing this module, then you can use your name here. If you have multiple authors, then use the same macro multiple times. Module description. You can give the module description using this module description macro. That will give you an idea to users. And finally, the module version. When we write a code, we will add a new feature, change the logic sometimes or very often, and fix the bugs. In that time, if we use a version to our code, then we can easily track. So, you can define your driver's version using this module version macro. That's all about the module information. Let's see some information about any of the drivers. First, we will list out the modules that are loaded into the Ubuntu LS mode. These are the modules that are loaded. We will do the same process in Raspberry Pi as well. Let's take the common driver in both the devices. I think this CEC driver is there in both the Ubuntu and Raspberry Pi. Use the mode info command to see the module information. See here, the license is GPL. The description is device node registration for CEC drivers. The author name is Hans Verkuil. Are you clear? Okay. Let's move to Printk. This Printk function is used to print your logs. It is like a printf function. Printk function has several log levels like these. Kernel emergency is used to emergency situation. Kernel alert is for alerting the user or developer. Kernel critical will be used in critical situation. Kernel error is used in an error situation. Like this, kernel warning, kernel notice, kernel info, and kernel debug are also available. See the example snippet. We are printing "Welcome to Embetronics" as an info message. You might have a question. If it is like a printf function, then directly we can use the printf function instead of the Printk. Why aren't we doing that? The printf function will be only available in user space and that's output will be redirected to the stdout console. So, we need to use Printk in the kernel space. We can see these prints using the dmessage command. In the newer kernels, they have created prinfo, prcont, prdebug, prerror, prwarning wrappers. So we can use that also. Let's see the init and exit function. Every Linux kernel module should have the init and exit functions. In object-oriented programming, you might have heard the word constructor and destructor. When you create an object, the constructor function will be automatically called. Like that, in the Linux device driver, when you load the driver, this init function will be called. Create an init function like this and register it with the module init macro. So, when you load your driver using this insmod command, it will call this init function. Exit function is like a destructor. When you unload the module using the rmmod command, it will be called. Create the exit function like this and register it with the module exit macro. Let's walk through the code. This is our hello world module. Include the header files. Then write your init function. In this init function, we are printing welcome to Embetronics. This is the simple module. Kernel module inserted successfully. Register this hello world init function using the module init macro. When we load this module, we should see these print messages in dmessage. Then create an exit function. There I am printing a kernel module removed successfully. Register this exit function using the module exit macro. At last, I am giving my module information like license, author name, description and version. We are going to load this kernel module. To build this source code, we need the make file. See the make file. I am providing the module name. Then I am storing the kernel header path to kdir. Then we will build the code with this make module command. To clean, we are using the make clean command. In the make file, you should not give space in this indentation. Instead, you have to give a tab. See here, I have helloworld.c and make file. Open the terminal and build the code using sudo make. Done. Check the files. See, we have helloworld.ko. Now, we can load this module to the kernel using sudo insmod helloworld.ko. Our module has been loaded. Let's see the dmessage. Our prints are here. Let's do the same process in the Raspberry Pi. Build the code. Load the module. Check the dmessage. Here also, we have got our prints. Use the lsmod command. It will give you all the loaded modules. See, our module is loaded. Let's run the modinfo helloworld.ko. It will print our module information. Now, let's unload the module using sudo rmmod helloworld. Check the dmessage. See the print. Kernel module removed successfully. Awesome. Now I will let you go. In our next video, we will see how to pass the arguments to the Linux kernel module. Just share this video with your friends and let them also learn. Thank you. Take care.